Hello, today we're going to discuss the quadratic formula, and this is how we handle some type of second degree polynomial where you can't really factor it. Let's go ahead and get into it. We're going to derive it, and this is obviously for grades 5, 6, 7, 8. Whenever you're in algebra, this is going to be the video for you. We're going to solve a second degree polynomial with in the ax squared plus bx plus c equals 0 form. Well, let's choose one that we just out of the blue that we can't factor, like maybe 5x squared plus 3x plus 1 is equal to 0. You'll need to use the quadratic formula for that one. Okay, so we're going to go ahead and derive it. Remember, a cannot be 0 in this. We're not going to be dealing with any first degree polynomials or binomials. We're going to be dealing with second degree only. And obviously the reason why a cannot be 0 is that we're going to have to divide a from both sides of the equation to try to isolate x. Okay, so we're going to be isolating the x here and have a whole bunch of numbers over on the right side. So isolating the x on the left side of the equation, we're going to have a whole bunch of numbers on the right side. The very first thing we're going to do is divide by a. So again, a has to be non-zero for us to be able to do that. So we now have x squared plus b over ax plus c over a is equal to 0. Subtract c over a from both sides. X squared plus b over ax is equal to negative c over a. Okay. Now, notice what I'm going to do here is I'm going to take this, drop it down, factor the 2 out of b over ax, but then I have to leave a 2 in the denominator. Okay. So you notice if I were to have 2b over 2ax, well, the 2 in the numerator and the denominator would cancel. Okay. But in this case, instead of letting them cancel, I'm almost like I'm popping them both out. Okay, I'm factoring both a 2 and a 1/2 out of my b over ax. Okay, so I have 2 times 1/2 times b over ax, but I'm going to leave it as 2 times b over 2ax. Okay, you'll see why I'm doing something so crazy in just a minute here. This whole thing drops down, and I have x squared plus 2 times b over 2ax plus b squared over 4a squared is equal to, and the negative c over a drops down. So I have negative c over a plus b squared over 4a squared. Okay, now notice what I have here. X squared plus 2 times b over 2ax plus b squared over 4a squared. Well, what is b squared over 4a squared? That's b over 2a squared, right? If you square b over 2a, you get b squared over 4a squared. So this is going to fit this form here. X squared plus 2 times b over 2ax plus b squared over 4a squared is equal to x plus b over 2a altogether squared. Now square this and you'll find that you get this. Okay, if you square x plus b over 2a, you're going to find you're going to get x squared plus 2 times b over 2ax plus b squared over 4a squared. Just like if I square x plus 3. Okay, so I have x plus 3 squared. I'm going to get x squared plus 6x plus 9, which is the same thing as x squared plus 2 times 3x plus 3 squared. Okay, so it's the same form. And you can try it for x plus 2 squared. You'll get the same basic form. But the bottom line is this will simplify to this. And this will the negative c over a plus b squared over 4a squared will simplify to b squared minus 4ac over 4a squared. Now that you can do on your own. All right, you can confirm that this will simplify to this on your own. I'll give you a hint. All you really have to do is find a common denominator. Okay, so to get a common denominator up here would be 4a squared. You just would multiply the 4a here in the numerator, and then the 4a in the denominator, and you'll get negative 4ac over, all right, well, I'm doing it for you. Negative 4ac over 4a squared plus b squared over 4a squared. I was going to make you do it on your own, but all right. So there you just flip them, and you get b squared minus 4ac over 4a squared. Okay, well, I just did it for you. But this one you might want to confirm on your own, just so you're sure that x plus b over 2a squared is equal to what I have above here. But anyways, what on earth did I do here? How did I took both sides of the equation here to the 1/2 power. Well, x plus b over 2a squared to the 1/2 power is what? Well, that's just x plus b over 2a, right? Just cancel out the 2. And then what's b squared minus 4ac over 4a squared to the 1/2 power? Well, that's plus or minus the square. You have to have both plus and minus as possibilities. The square root of b squared minus 4ac over 4a squared, which is the same thing as the square root of plus or minus b squared minus 4ac, then that whole thing altogether divided by 2a, and the 2a would not be in the square root sign. Okay. Well, I subtract b over 2a from both sides, so x plus b over 2a minus b over 2a is just x. And then I bring this down here and I subtract b over 2a from that side, but I'm going to leave my, so that's going to be negative b over 2a plus or minus the square root of b squared minus 4ac altogether divided by 2a. Well, notice I have 2a as my common denominator, so I can just leave that as x is equal to negative b plus or minus b squared minus 4ac. Excuse me, x is equal to negative b plus or minus the square root of b squared minus 4ac. All the whole thing all together divided by 2a. And so that's my quadratic formula in a nutshell. It's derived, and now you can use it for, so far you've been just factoring things like, I don't know, x squared plus 5x plus 6 is equal to 0. Okay, you've been factoring that, and then you have two different binomials that they're equal to 0, and so your x can be, you can take either one of those and then solve for x in either instance, and so you have two possibilities where x is equal to 0. But in this case, you can now find x is equal to 0 for even things that, even second degree polynomials that you can't factor. So that's it in a nutshell. Thank you.